they put this webinar together. We are honored and we are really excited to have Mr. Stefan Escanes from Metric Engineering with us today. So Stefan is a graduate from Florida International University, has more than 13 years of experience as a professional traffic engineer. Having been with Metric for more than 10 years, Mr. Escanes currently serves as a project manager and transportation planning manager at Metric Engineering, where he is responsible for co-leading projects in Florida. Mr. Escanes has a comprehensive understanding of the needs and requirements of various traffic operations. His expertise includes transportation planning, signalizations design, active arterial management, general about signals, adaptive traffic controls, transit signal priority, smart work, smart cities, and so on. Mr. Escanes has prepared traffic analysis, in-depth traffic modeling, and simulation services, and has completed several data-intensive large-scale projects through the various TSM&O traffic operation projects, signalization, transportation planning, and different studies. And we are really interested to see what Stefan is going to talk to us today. Stefan, the floor is yours.
Thank you, Dr. Kaiser. And really, from a topics perspective, when presented with this opportunity, I try to think back as to when I was a student and what is something that I didn't know that maybe would be interesting to know. So from a traffic engineering experience, from a traffic engineering perspective, try to find something that is pretty interesting. Not always the easiest of tasks, but we'll give that a try here today. So Dr. Kaiser already kind of gave an intro there for me. Appreciate that. So I'll skip over this. As you mentioned, I am a consultant working for Metric Engineering. Metric is a full service firm. So really the idea is to take projects from concept to completion and beyond, such as operations. So from a full service perspective, what that means is, we do planning, we look at environmental, roadway engineering, traffic engineering, connected vehicles in the future, and all of those elements. So a quick outline of the presentation. I think the first step really is taking it from a higher level, understanding just in general, what is FDOT, Florida Department of Transportation, what is their vision and mission? From a traffic engineering, so there's a traffic engineering office, how is that broken up? And then what is a traffic study, at its core? And then, as a traffic studies consultant, well, how do we determine which study we're going to do? What type of services do we give? And go through a sample study. And then I think really the cool part, one of the coolest parts, is the incorporation of technology. Just over those 12, 13 years of experience, I mean, technology has changed dramatically, and I can only imagine what it will be like for you students in the future. So looking at the vision and mission, so you have FDOT as a whole, where their vision is really, providing the transportation network that is well planned, supports the economic growth, and provides a congestion fatality-free transportation network. Its mission is to deliver this in a safe manner, to ensure the mobility of peoples and goods, as well as enhancing economic prosperity and the overall quality of environment and communities. So digging a little deeper at the Traffic and Engineering Operations Office, and their vision is really to be a leader when it comes to mobility, and a national leader. And I think FDOT has been definitely proven in living up to that vision. And from a mission perspective, continuously improve safety and mobility through traffic engineering and other elements such as Target Zero type initiatives, which really Target Zero is really getting into how can we eliminate severe and fatal incidents. So as I mentioned, we have FDOT as a whole, then we have the traffic engineering office. And again, this is really a high level overview, because I guess, even when I was in school, FDOT, what do they do? How are they set up? These are all questions that I don't even think I knew to ask the question. So under FDOT, you have a number of different offices, design, structures, and traffic engineering operations is one of them. This is then further broken up into 4 different divisions, which is traffic services, transportation systems management and operations, traffic incident management, and traffic systems. So today we'll be looking at what we do here under traffic services, mainly intersection operations and safety. And then you have all these other components that are included, including maintenance of the traffic engineering manual. So one of the key resources where that as engineers we go to when we're evaluating and performing these studies. Then you have the transportation systems management and operations. This is a lot of the technology side, communications, and everything upcoming related to connected vehicles and more. Traffic incident management, I know for sure, when you've been on the highway or freeway, you've seen road rangers, with the FDOT logo. Maybe you've had a tire, go flat and pull over, and they come out and help. This is these services that are provided, including hurricane response, which has been pretty active as of recent with Hurricane Ian. And then the overall traffic system. So what devices are out there? Your traffic signals. When you look at a signal head, red, yellow, green, those light bulbs, all of this is on a list, on an approved products list. All of these components are tested. And so this is where all of that occurs. So what is a traffic study? Some of you may have taken the highway capacity manual course. That gives you insight into how to evaluate the operations of an intersection or a freeway, and some of you may not have yet. So overall, a traffic study is an engineering investigation, and it's to evaluate a transportation system or component, an intersection, or a segment of an arterial, so a segment of a roadway between one street and another. And its purpose is really to identify and document deficiencies, determine what improvements are warranted. That's where we look at a lot of these studies, these manuals here, and then this is these traffic studies are really a vital part to the vision and mission to enhance safety and the performance of the roadway systems, because it serves as an avenue to evaluate what those deficiencies are. What are the problems, when you're stuck at a light, or there's too many cars on this street, there's frequent crashes at this intersection. So this gives us an avenue to correct those deficiencies. So then what goes into a traffic study? So each traffic study is a little different. They all have their own issues. So we want to look at what the intent and purpose of that individual study is, collect data that will be used to evaluate that specific condition, and then also at times for different types of studies, we'll project traffic, meaning that we'll look at what will be the volume on a roadway or intersection 20 years from now, 10 years from now, and try to anticipate those congestion and those capacity issues, so to attempt and alleviate that in a proactive manner. Ultimately, we gather all of this data, all these projections, and analyze it by applying our engineering principles. So again, if you've taken the highway capacity course, that's one of the basis of principles when it comes to the overall operations. And then again, making use of all of these resources that have been developed over the years by FDOT, by FHWA, which FHWA is the Federal Highway Administration. So at all these levels, there's just resources that we can look to, and taking all this data to identify any improvements. So now that we've kind of looked at an overview of the structure of FDOT, what the study is. So again, as a consultant and providing these services, not just at DOT, but really providing these services to improve the roadways that we drive every day, is a pretty neat feature. It's something that you're often in a sense excited about, and kind of want to do your part in giving back. So through different contracts within that traffic service division, for example, the one we're talking about today, these are some of the services that we provide. And it ranges from just an overall qualitative assessment of just looking at an issue and maybe determining that issue and what additional study may be required. And then you look at whether an intersection where it's currently stop controlled or has no control, and does it warrant a new signal? Looking at intersections, arterials, so on and so forth. And to say, we're not short of studies. So these are, for example, just the number of studies we've done down here in District 6 as metric engineering, over the past several contracts. And so you can see they're always coming in. So, that's great, but how do we determine which studies to perform for traffic ops? So the map here now this is all the requests over about a 3-year period that have come in the Miami-Dade County area, and there's some more in the Monroe County area as well. But you can see, again, not short of requests for studies. So, the way this happens is, as a citizen, you drive every day from your home to the university, and you go through certain streets, or when you're coming out of your neighborhood, you're stuck at a light, and it's there's congestion, and there's issues that you see, such as like, hey man, like there's nobody on the other street, I should get the green light, or you're at the stop sign and it's nearly impossible for you to get into the traffic stream of the major roadway, or there's crashes that occur at a specific intersection that you notice. So whether it's you as a citizen, a homeowners association, the county and city representatives, or another agency, they generate a request and reach out to FDOT as the roadway owner. And each request that comes in is tracked. It's assigned a number, and then this number is then assigned to a study team. So this is where our services come in, where basically we look at what the identified issue or safety concern was. So we review that request, and let me see, just going back one, we look at these different service types, which we also have here, the other traffic engineering related studies, which you get requests that kind of don't fall under a specific category at times, and you develop a set of work. Again, we identify the problem, we identify what the data collection we're going to need, so we can evaluate the concern appropriately. And so we go ahead and perform that study. Once we're done with the study, FDOT then takes that study and provides those results to the original requester, which may have been the citizen, homeowner association, county, city, agency, and such. If that study includes recommendations, improvements, and such, there's a few avenues it can take. It can be assigned to a specific design contract where another engineer will now go into a more in-depth design of the improvements. So let's say we identify that where you are always stop at that stop sign for minutes on end actually does require a signal, well, now someone will go ahead and design that signal. And then there's also here within the district what's called a scoping committee. It includes all the different disciplines of FDOT, and we present the improvements and recommendations so that they can add those improvements either to a project that's coming up or create a project for that so that it can get designed and built. So taking a look at a sample study, try to pick one with a few different elements to them. So this location, this was a location over in Miami Beach. The concern was for the crossings at 67th Street and 65th Street, that it didn't have the right pedestrian features, such as, the button you press for the walk sign to come up, and those type of elements, not enough time for somebody to actually cross. And then there was also concerns about pedestrians and vehicles in conflict. So let's say you're crossing the street. I know this has happened to all of us. You're crossing the street and maybe there's a vehicle turning and there's a conflict there. And there was also a concern about speeding between this segment here as well. So since this involved several different elements, this is kind of what I mentioned, where it kind of falls in under that other type of study where you kind of pick the different services required to evaluate these concerns. So beginning from a traffic study, that first component that we talked about, data collection. So from a data collection, we want to know, all right, so there's a concern about speed. So what are the speeds on that segment? What are the volumes on that segment? What are the specific turn-in movements that are occurring at the intersections? How many people are making a left? How many people are making a right? Pedestrian counts, how many people are crossing the south leg crosswalk or the east leg crosswalk, and then also obtaining the actual signal timing plans for the signalized intersections, so we can then model the intersections appropriately. So taking a look at some of the volume and speed data that was obtained here. So you're looking at, basically a pretty graph, right? A lot of colors. But ultimately what this is showing is that in the northbound direction, vehicles volume, the number of vehicles between 31 and 35 miles per hour, 36 and 40 miles per hour, are about 150 to 200 here in the morning peak. And also, later in the PM peak, also going a bit higher as well in terms of number of vehicles that are speeding. The speed limit for this area is 30 miles per hour. So these are all the vehicles above that speed. Within in the southbound direction, you can see here this is a bit more flat, so not as many folks are speeding. And within that initial 31 to 35 range is a bit higher here in the morning. Here we have pedestrian counts. So for example, when we look at pedestrian and vehicle conflicts, we want to know, so, what crosswalk has a lot of pedestrians, and then what movement has a lot of cars that those pedestrians and cars may be coming into conflict. So, for example, sorry about that. So for example, between 4 and 5 p.m., pedestrians crossing the eastbound crosswalk, there was 16 pedestrians, and so on and so forth. So we use this information then when we're looking at those conflicts. Something you always will be performing as part of these studies is going to the field. Nothing replaces a good field review and observing these concerns firsthand. So, again, you can kind of see here pedestrian and a vehicle in conflict. Right now, basically, they have the countdown going with the pedestrian having the right of way. Also, there's a concern about pedestrian features. So, we looked at all the different type of signal heads and push buttons and, what is currently installed at the intersection. So here, you have all the countdowns, but at this intersection, you have a few movements without countdowns. So, you'll definitely want to look at upgrading those so that, when you're crossing the street, you know how much time you have left to actually cross the street. And then also looking at the overall operations, any type of queues or congestion that's occurring at the intersection. So as I mentioned, we collect a lot of traffic data so that we can evaluate the operations of the intersections. So in this instance, we performed a level of service analysis. Again, for those who may have taken highway capacity manual, you probably know what level of service means. If you haven't, basically level of service is a way to grade operations from A through F. So, just like any type of test, with A being, all right, you did good, F, not so good. So in this case, E and F are failing types of operations, considered deficient. The target, what we usually try to target is at least a level of service D or better. So basically, we get all this data that we collected previously, pedestrians, turning movement counts, signal timing information, and we plug it into this program here, which is it's a traffic-aware synchro model. Coming out of school and starting to learn a little bit of synchro, to me that was pretty fun. If you're into gaming, if you're into those type of elements, this is always a pretty neat feature. Not only do you have this static view, but you can also run the simulations for it. And this is a fairly basic software, this one. However, it gets pretty complex. So, again, if you're into computing, coding, and all of those elements, you can get into more sophisticated simulation models, such as PTV Vism or AIMSUN, and there you can really create some really cool 3D simulations and basically simulate just about anything that you want. So that's always a pretty fun task when you get into that element. So taking a look at what we evaluated here for these intersections, we looked at adjusted. As I mentioned, they're considered about how much time they have to cross the street. So, we adjusted the pedestrian clearance, so how much time they have to cross, and then also evaluated what's called a lead-in pedestrian interval. What this does is that, let's say here you're on this east leg going westbound. So before you get the green, it's going to give the walk phase to your crosswalk for 5 seconds. That really allows the pedestrian to enter the crosswalk, gain visibility, and have that right of way, so that by the time the side street has the green, the likelihood of complying with yield into the pedestrian is much higher because you've already entered the crosswalk, you're already there. So that is the other element that we looked at. So you can see here results for the 3 different scenarios, with the existing really being your baseline, so you can compare your potential improvements. So as you can see here, adjusting really didn't make much of a difference, and LPI, while it did increase a little bit, some delays, overall, pretty good as well. So taking all this information, the identified speeding, the operations, if we did implement these modifications to the crosswalk times, from there we go ahead and develop recommendations. So in this case, it was recommended to implement lead-in pedestrian intervals. The way this was done is basically summarize all the signal timings and simplify it by highlighting all the changes that are necessary to implement the lead-in pedestrian interval. So like that, when you're coordinating with the maintaining agency, which in this case is Miami-Dade County, because they maintain the overall signal timing and operations of the signals. This simplifies what changes need to be made. And also based on the speed and the effectiveness of speed feedback signs within about 1,000 feet is typically pretty effective, which in this case, it's a somewhat short segment. So installation of a speed feedback sign was recommended. And you can see here that from basically having gone from the study into implementation. So with any recommendations, so these are recommendations specific to this study, you always want to consider the constructability element. So if you're adding something, to a mast arm and to a pole, you want to know, well, can that structure handle that additional load? If you're modifying the pavement or adding more pavement, so how is the drainage going to work, now that you have more pavement? Or if you're impacting trees, what's that environmental impact of relocating those trees or impacting those trees? And then in this case, for example, what power source should be used for this sign structure? Should it be a grid power? Should it be solar and such? And so you want to evaluate the implementation, feasibility, and constructability of those elements when you're recommending them, so that the recommendations you give can move on to the next step. So one thing about the traffic operations office that we like to kind of say is that it's kind of a micro ecosystem of the FDOT as a whole, because you're dealing with all of these different little elements at a smaller scale, and so you really need to consider all of them when you're working through these studies. So beyond an example is how we continue to incorporate technology. As I mentioned, over 10, 12, 13 years, I mean, the technology has been incredible. And then by the time I started working, some folks would say, man, are you lucky to have Google Earth, and things like that. And, as just, metric in general, we really try to leverage technology. We always try to stay at the forefront and cutting edge of the latest technology, because it really helps us gain efficiency and allow us to do more to improve operations and safety. So from a drones perspective, when I started, there were, drones were not widely used. I'm sure plenty of you have your own drone, know how to fly a drone, and for personal use. And so, here we have basically FAA certified drone pilots. So we do take a course from a safety perspective and making sure we're flying it appropriately. But I mean, the use of drones has allowed us to do many things. And in this case, I kind of wanted to bring up the bottleneck and identification and prioritization study that we performed, where I looked at basically, a ton of corridors, which I'll show you a map on some of the next slides. And it allowed us to really identify, this intersection that's right over here in this corner, how much does it impact? The intersection that's over here, how much does it impact? So, how much are these intersections and lights that you drive to and you're just stuck there and waiting and waiting, how much impact is it causing? If you have a half-mile long impact, really without a drone, you have to walk that half a mile. You have to, if you're at the intersection, you're going to look down, you're going to try to take a picture, zoom in and such. But with a drone, you get these aerial footages. You can see, how you have the impact at this intersection, how these guys here are trying to get in. Here, oh, this looks nice, right? But man, this is a pretty long queue that they have going here. So this really allows us to identify the full extent of impacts for large areas very efficiently. And then also the duration of that impact. how long is this lasting? So as part of this study, not only did we do this, but we were able to then also collect with other data collection technologies, a number of traffic counts, turning movement counts, so you can see all the yellow dots, all the blue dots, collecting travel time along the segments. And this type of table is not to go through it. Trust me, it's just to show you what is capable with this additional technology, how we're able to collect, over 100 miles and 150 different locations of data, and process it in a short amount of time, where maybe before it required somebody, for the turning movement counts, for example, before it required somebody sitting at the intersection with a board and just counting. Now you can, you can set up a camera which identifies little that drawing little image squares, and they're recognizing, and it processes the image and counts all your vehicles for you. And then you just have to make sure that it counted correctly instead of standing out there for 12 hours. So, this really allowed us to perform this significant study, and the efficiencies and data collection technologies are really only evolving. So if we're able to do this now, I mean, in the future, it's only going to get easier and better and more sophisticated. But basically, all that information was plugged into this large matrix, where we were then able to quantify and assess all of these 50 different key locations. And again, this kind of just shows you the extent of all the information that was collected over all of these corridors. And this was all performed within a 3-month period, from between March and June. So, this again just shows the extent of what is capable, where this probably would have taken, previously closer, I want to say, to a year. 10 years back, for sure, at least a year, just the sheer amount of locations. So again, we were able to go to the field and do all of that. So, from a field review perspective, you can't get away from not going to the field. You have Street View, you have a lot of tools that can give you a good assessment, but it doesn't replace going to the field. And then when you go to the field and you want to take notes, you have your notepad, your pen and paper, you're writing it down. Then you have to go to the office, transmit that. Again, ArcGIS has changed the landscape. We're able to now develop applications that you go, just with your iPhone, just with your iPhone, take pictures, pinpoint them. If you have to take an inventory of all the signs and all the information that's there, everything is already pinpointed, geolocated, when you're in the field, and it's already uploaded to your database, ready to just basically simplify your report production, your plans, and such. So here's, for example, an example of an observation, where you just kind of, once you're in the office, you can click on the dot, you have your image that you took, what the observation type was, and your image caption. So not only is this great for just your one study location, right? But now if you zoom out and you've done, as I've shown you before on those maps, all those CTP requests and all that, I mean, that builds a significant database of information, historical records, and really centralizes all of your efforts into one location, where you can, again, it just really allows you to do so much more with this technology and these programs and applications. Crash data, same thing. Yeah, if you've been in an incident, the police report that was written up, that eventually makes its way to a database where traffic engineers can access that data. There's a ton of different fields that they have. So, if you've been in an incident, you're already a little frustrated. Now you're like, what's taking the officer so long and such? Well, there's all this information to implement. It's really to the benefit of everybody. It allows us to really analyze the causes of incidents, and then with the location of them, it allows us to really evaluate, large corridors. For example, this is Southwest A Street. I want to say there was about 1,100 incidents that were, recorded here. So, you can see pinpoints, but then also if you want to, all right, let me take a high level look and identify hotspots. So, okay, rear ends, they occur a little bit throughout. Parked vehicles, all right, we have some more instances here. Well, there's, parking, side street parking, so it makes a little bit more sense, but here, well, there isn't. So what's going on there? Angle crashes here, some intersections as well, where those occurring most. So it really allows you to expand your evaluation, and really pinpoint what those improvements are needed by having a better identified problem. Again, with technology, we want to leverage the overall technology, what's coming. We know what was in the past, but what's coming up? What projects are coming up? And there's a lot of technology-oriented projects coming. For example, Miami-Dade County is upgrading their entire signal system. So again, when you've been at a light, it's red, it's green for the other side. There's nobody there. You're like, come on, man, give me the green. So this is what adaptive signals look at. There's additional detection of vehicles and more algorithms coming into play to improve the efficiency there of those traffic signals. Then there's also what's called automated signal performance measures. What this is basically is detection information. So the little cameras that you see sometimes above the traffic signal, that's counting how many, maybe counting how many cars in addition to detecting them. When does the car does it get there at a green light, at a red light? So it takes all of these statistics and gives us those statistics, and all this information just helps us plan better, identify issues, and be much more proactive instead of perhaps waiting for a CTP request to come in. So it allows us to be more proactive. There's a lot of TSM&O master plans out there. So again, TSM&O, that was the more technology division of traffic operations. There are a ton of planned projects. In this case, Smart Plan. Basically, this is a large transit initiative to increase the amount of transit and rapid transit. Connected vehicle project down in the Keys. And then you also have here a map of, which roadways are being monitored. So, maybe you're driving here and there's some cameras in the corner of the intersection and other devices. And there's engineers and operators looking at the conditions there and always working to improve those. That's something that also, we have a ton of experience in. As I mentioned, we're very technology driven. So we like to incorporate these as part of traffic operations. So even though we're looking at traffic services, TSM&O is the division just over one. So, we want to take into consideration what's there. As we're evaluating specific locations, if we identify something that can, leverage what's being done from the other division, then, it's good to document and identify those so that we can further enhance operations and safety. So again, with that, it comes to, all these master plans, what's coming, what's going to be deployed, smart work zones, just deployment of additional camera and other devices to monitor the work zone and try to improve traffic under those constrained conditions. When you're going through a work zone and you have one less lane, it always makes it a little bit more challenging. So, if somebody has eyes on the road there and can try to improve that, then that's again a benefit to the traveling public. Your traffic management center operations that look at all those monitored corridors and retiming signals and such. So really with that, that's about it. Kind of wanted to leave some time here in the end for any questions. And yeah, thank you.
Great. Thank you so much for your presentation. The chat box is open for
Okay.
questions.
Got it.
So I don't see any right now, but we'll wait a couple minutes for see if anyone has any questions.
Don't be shy, folks.
So we do have a question from Sai. How can the survey be done?
How can the survey be done?
Could you?
So,
Yeah.
am I able to see that in the chat box? Is that in, I guess, in relation to, if that's in relation to the field reviews? Or is there a survey on the overall presentation? I'm sorry.
Sai, if you could elaborate on that question, that would be perfect for us. Thank you.
Unfortunately, I see the questions coming in. Okay.
So while we're waiting on elaboration from Sai, we do have another question. How do you prioritize issues/tasks, and do you have performance or evaluation metrics?
So for an individual study, really, for an individual study, from a prioritization of issues, you're looking at what the concern and what the request was. Sometimes when you're evaluating these, you'll find other elements and you'll recommend those as well. So from these specific studies, I guess there's really not an overall prioritization of issues or tasks. It's more addressing the issue at hand. If there is a prioritization factor in these studies, it's typically more of a short, mid, and long-term improvement. So you'll be looking at, what can we do right now to help? So we'll provide that information. What is something that, for example, here when they're in scoping committee, maybe another project can implement a type of improvement, and then a bigger project down the road can implement an even better improvement. So a lot of times the prioritization and issues for issues within these specific studies, I would say, is more time frame based. Now, when you're looking at a large scale matrix and comprehensive analysis such as this one, you'll develop, again, an assessment matrix. You'll, we have, for example, you'll set parameter scorings. So in this case, we had all of these different criteria based on the data that was collected and parameter scoring that was applied. So then here, basically your total scores, you'll then rank those accordingly. And actually that was what was done. In the end, this was the final ranking, and these were then pushed on into individual studies to identify improvements for each one. So from a performance and evaluation metrics, in this case, we looked at, duration was key. What was the bottleneck impact area? And then you can also see here how many points is each one worth. And so when you're setting up these type of weighted sets of criteria, you'll kind of run it by different engineers and get a less biased type of scoring, and that that goes into a whole nother realm of sensitivity analysis and other elements. Something that's done on big planning studies when considering, should we widen the road to the left side? Should we widen it to the right side? Quantifying all those impacts. So in this case, those were kind of the performance metrics used for this specific study. But yeah, you do base really everything on performance and evaluation metrics. So I hope that answers the question.
So we have a little more elaboration from Sai. I don't know if it helps you understand what he is asking. So he is asking how the survey can be done. Is there any preferred mode? Is it data grouping from sources or any other ways?
So in general, there's key available sources. So for example, when you're looking at, crash data here, there's a database, there's official databases basically available, such as the Crash Analysis Reporting System, which is an FDOT database of all the crashes. There's also what's called Signal 4 Analytics, which is also ran out of the University of Florida. And those are kind of working together, and that provides us with an official database of crashes. So we're able to evaluate those crashes. So then from a survey perspective and methods, there's no right or wrong way. Let's say when you go to the field, you definitely want to take pictures and take all of your notes down and such. But I guess as time evolves and technology evolves, I think the key thing is making it as efficient as you can from the field to the office, so that everything you observed in the field is very easily translatable into a report. And it just makes everything easier. It makes it simplifies it on your end. It provides a better visual for FDOT and for everybody. And again, it kind of records the overall database. So I think related to the performance, that's really related. How you do the survey is also related to the performance and evaluation metrics question, where what metrics are you going to use and what is the source that you're going to use. So there's a lot of services that look at estimating data on roadways, but then you can also collect that data, with what's called, tubes that connect to a device that allows you to count the number of vehicles, or the cameras, as I mentioned, to count the vehicles. So there's a lot of different sources. It really depends on what metrics you're trying to obtain.
All right, is there any more questions from the audience?
Any other question from the audience? Any thoughts? Mackenzie, do we have any other event? is coming up?
Yes, Mr. Escanes, I would like to thank you for presenting for us today. Our future webinars, we have one October 26th, Wednesday, 12 p.m. This is done in correlation with WTS. So we have presenting Ms. Haley Vaughn, and she is presenting Evaluating Your Transportation Equity Planning with Replica Data. We also have for students, Mr. Shelby Koch coming in to present for us his company, as well as Diverging Diamond on Glades intersection. We do have more information regarding our ITE, WTS, and FMRI events on our website. It is FAU FMRI events, and it should pop right back up. Thank you so much for attending.
Stefan, I would like to thank you. I would like to thank you for this great presentation on behalf of the FMRI, FAU, and the IT student chapter. We are looking forward to see you because you are in the same area. We are looking forward to see you on campus, to work with you, the facilities, and we meet with the students. And we really appreciate it, and we are looking forward to see you, in the future. And with that, we would like to thank everyone that participate. We are looking forward to see you in the future webinars. And with that, I would like to give it to Mackenzie so we can conclude this webinar today.
Thank you.
Thank you, everyone. Have a great day.
Thank you. Bye-bye.